Hi everyone, this is Gio, and today I would like to share with you one of my personal projects that I call PISCES, the Pi for every Lambda. PISCES is the acronym for PicoLisp in Silicon Chip Evaluation System. The Pi for every Lambda means that PISCES is a single board computer designed for every Lispers. It uses PicoLisp as its main programming language. Okay, before I proceed, let me tell you some bits about me. My name is George-Phillip, and everyone calls me Gio for short. I'm an embedded software engineer, and I have developed firmwares for different MCUs for the past 10 years. I love to build things that utilize both hardware and software. And one area that interests me most is the unconventional computing, which is also the reason why this project was conceptualized. So how it all started. When I read about the Unix operating system, which were running on a RISC-based workstations, I immediately got very interested with these machines because most of the time I only have access to Intel-based personal computers. From there on, I've always wanted to try using a Mac, Sun, SGI, or a Next computer. When I was working in China, I found affordable used Unix workstations on their local eBay called Taobao. I grabbed the chance and collected some SGIs, then joined a forum for SGI enthusiasts called nikochan.net. One of the members in that forum posted about Lisp machines, and since then, I cannot stop reading about this very intriguing computing system. It was more unconventional than Unix and RISC combined, so I was targeting to add a Lisp machine to my wish list. But because Lisp machines are very rare these days and expensive for a hobbyist like me, I just decided to build one using an FPGA. My first attempt was to implement the unreleased LMIK machine as documented by Joe Marshall. But because the system contains a lot of programmable array logic chips, and most of its documents were long gone, it will take a long time to reverse engineer each chip's logic by referring only to the schematic drawing and the remaining documents. To move forward, I decided to look for a modern Lisp dialect that is small in size with a decent performance. Then I found PicoLisp by Alexander Berger, which fits most of my agenda for a small Lisp machine. I immediately contacted Alex and told him about my story. Since then, he also got interested to have an actual hardware implementation of the PicoLisp virtual machine. I was working on the Verilog side while Alex on the Lisp side. After some months of work, we announced the PilMCU last August 2014. But because I was still new with Verilog, that version was only runnable in a simulator and the whole code was not synthesizable. So I had to refactor almost everything in order to have it run on an actual FPGA board. Due to unavoidable circumstances, the progress became slow. It came to the point that the project was labeled as a vaporware, but I still pushed through. To fast-pace the development, I decided to design my own FPGA development board and hand-pick all the necessary components that will also help me ease up the Verilog coding. After almost 2 years of working on this project, I am very happy to present to you the output. It's a single board computer similar to Arduino, Raspberry Pi, and BeagleBoard. A picture of it will be shown on the next slide. The main difference of this system from the others is it is powered by PilMCU softcore, which is loaded into an FPGA. Because of its Lispy nature, the machine has a built-in REPL which is used to program the system. So, imagine an MCU programmed interactively. This will provide a new level of rapid prototyping for embedded systems. Also included is a line editor and file system implemented in plain PicoLisp by Alex. The line editor is capable of paired parenthesis checking, autocomplete by tab key, as well as command history recall by up-down key. The file system is implemented using PicoLisp database concept. Here is the picture of the whole board. As you can see, there are some dangling wires. These are hardware tweaks to address some preliminary design issues. The programming interface is UART. It only needs 4 pins: TX, RX, 5 volts, and ground. There is a jumper options used for programming the ROM or the SSD. For power source, there is a micro USB port, so you can use your smartphone charger or your power bank. I'm using an off-the-shelf FPGA board which contains an Altera Cyclone 4 FPGA. For the ROM, I'm using FRAM, which has a better performance compared to the traditional BIOS chips. For the RAM, I'm using a synchronous SRAM. This is usually used in cache memory because of its speed. Since this is still a prototype, memory size is not yet considered. The current size is 16 MB, but upgradable to 32 MB. For the storage, I'm using NOR flash memory, which has a faster read compared to the usual NAND flash memory found on most SD cards and SSD drive. Current size is 512 MB and upgradable to 1 GB. The board have 3 volts and ground pins that can be utilized by other boards. It has a BCD display to demo some output port capabilities, but currently I'm using it to show the program counter for debugging purpose. It has some tact switch for input port demo, but as of the moment I have not soldered the switches yet. This will be in the next agenda. It has 2 sets of I2C port, 2 sets of SPI port, and 1 UART port. This board was designed to connect with some off-the-shelf devices that I picked to be used as building block for a standalone system, to be shown on the video. But as you can see, there are the connectors for the following devices: a VGA PS2 module, touch LCD module, a Wi-Fi module, and an Ethernet module. As of the moment, the demo video only covers the Lisp environment. The I/O ports are still not yet implemented, but already a work in progress. Hi everyone! Meet PISCES, the single board computer intended for Lispers. So let's start by connecting PISCES to the host computer. A host computer can be any computer or any system that is capable of teletyping using serial communication. In today's demo, I'm going to use my Windows PC. So these are the pins related to programming the board. Let me give you some details. This pin is for the jumper option, which is used for mode selection. And as you can see, there is no jumper right now, so it means it is in programming or REPL mode. If we use a jumper to connect the first 2 pins, this means we are in ROM update mode. And if we move the jumper to the next 2 pins, this means SSD update mode. For this pins is for the programming connector. So pin 1 is 3 volts output. Later part of the demo, I will show you the usage for this pin. Pin 2 and pin 3 are RX and TX respectively. Pin 4 is GND or ground. Pin 5 is no connection. Pin 6 is 5 volts input. This is where you input the 5 volts power supply. And pin 7 is 5 volts output coming from this micro USB. So you can use your smartphone charger or your power bank to power the board. And if you do that, you need a jumper and short this pin 6 and pin 7. But in today's demo, I'm going to use an off-the-shelf USB to TTL UART cable, which is this. So as you can see, it's USB, and the other end are 4 exposed wires, which are green is TX, white is RX, red is for 5 volts, and black is for ground. So let me connect this to the board. But because we already have a 5 volts wire, so we don't need this jumper. So let's start with TX going to the RX, and then RX goes to TX, and then ground goes to ground, and 5 volts goes to 5 volts input. And then let's connect this USB to the computer. So PISCES is ready to communicate with the host computer. And as you can see here, this is the program counter, and you notice it's not moving, so meaning there's no process going on. It's because I added a logic that during program or REPL mode, PISCES or PilMCU is waiting for the user to enter the key, which is the enter key. So in order to do that, let me shift the camera to my screen. So I hope you can see my screen clearly. So let's start by opening TerraTerm, and as you can see, we need to choose serial, and you see it found my USB to serial cable, so choose that one and click OK. And before we can move forward, we need to set up two things. First is here in terminal, we need to change the new line to LF, both receive and transmit. Okay. Next is serial port. We need to change the baud rate to the maximum speed because of the binary updates or downloading the binary files. And because of this demo, so that you can see the text properly, let's also try to change the font size to 18 and then move this to the middle. So there you go, it's ready to start, but as I have mentioned, the board is waiting for the enter key. So if I press other keys, so there's no startup happening. But before I proceed by hitting the enter key, let me show you first how easy to upload or download the binary files for the ROM and for the SSD. So these are the files. So rom.bin is for the ROM and db.bin is for the SSD. So let me put this jumper to the first option, which means ROM update. So, and after that, let me reset the board, and as you can see, there's an R, which I use to indicate that the PilMCU is waiting for the binary file for the ROM, which is rom.bin. So let's go here. So as you notice, we all do this here in Terra terminal. So send file, let's go to desktop, and yeah, before we choose the file, let's check this option because it's a binary file, so we need to set the binary and check, then choose rom.bin and open. Then there you go, it's downloading, and as you can see, there's a C and G. The small c I use to indicate that it's checking, and capital G I use it to indicate as good. So it was successful. So now let's proceed by SSD update. So let me clear the screen first, and then let me move the jumper to the next option and reset again. And as you can see, there's a capital D, which indicates that it's waiting for the db.bin file. So same steps, send file, and then check the binary option and choose db.bin, then open. Then it's uploading, downloading, and as you can see, there's a still C and G. C for checking, G for good, and W. W here means it's writing, because for the SSD it's a bit slow. What I did is I cached the data first into the RAM before writing it to the SSD. So that was it. So it was very easy to download ROM or download to the SSD. So let's proceed, clearing the screen and removing the jumper option, so that we will go to the programming or REPL mode. So after that, let me reset the board, and as you can see, there's nothing happening because it's waiting for the enter key. So let me hit the enter key. So as you can see, PilMCU and heap 16 megabyte. So now PilMCU is running, but currently we're waiting for the prompt. It will take about 20 or 23 seconds because it's reading the file system from the SSD, which is in database, and also it's loading some programs like the line editor. So now you can see the prompt. So we are ready for the REPL now. So okay. So now that the REPL is ready, let's try some Lisp code. But unfortunately, I'm not fluent with PicoLisp yet, so I will just try some very basic codes. So first, let me try some addition. 1, 2, 3, 4. Shows 10. Let's try some subtraction. 4, -8. And let's try some multiplication, which is 24. And then let's try some division, which is 1, 2, 3, 4, 0. Let's try another division, like some obvious one. So let's just try. Okay. So then let me try some codes snippet from Alex that we used to test during our development. So like this sort. It's already 1, 2, 4, 5, 6, 7, so it's working. Then here's another code, test code from Alex, which is make 240 link rand, which means random. So closing, as you can see, the close, or I mean the parenthesis checking is working. So there you go, random numbers. So then let's try to make a function, which is very common in Lisp environment. So let's do which is this is also from Alex, which is the factorial. So dot n, then if equals to 0 and 1, and then multiply n by real decrement and close, 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 and close. Then enter. So factorial. Then let's try that function. Factorial of, say, 10. It shows 3,006. Oh no, 3 million. Let's try a smaller number. Factorial straight 3, 6. Okay, so it was for the REPL, so it's working. So next is for the line editor. So you have noticed that it was able to do the parenthesis checking by moving the cursor. And so that's one feature of the line editor. Another feature is it's capable of history recall by using up-down keys. But because the line editor is based on VI, so instead of using up down arrow keys we have to use K and J, but pressing escape first. So let me try that one. So escape K. So as you can see, it was recalling. It was up, then down, down. It's recalling the previous commands that we inputted earlier. So history recalling is also working, so it's really cool. So after that, you choose that one, press enter. So as you can see, it invokes the command that we choose. Another feature of the line editor is it can do command auto complete of the command. So let me try some because factorial is already here, so we can try that by pressing F and then use the tab key. So these are some PicoLisp functions. So let's wait until, so there you go, it found a fact. So let's try a 5 then. So there you go. So that was all the nice features of the line editor. So let's proceed with the file system. So for the file system, it is implemented by Alex using the database feature of PicoLisp. So let's try this. Let's try by showing what is inside. So this is the DB, but let me use another function which is more readable, which is directory. So now you can see that it contains live.l file and two directories, which is live and you can check what's inside of each directory by using same. So as you can see, directory, then live, I can use tab to autocomplete. So as you can see it, and then so that's the contents of the library. So there's a boot.l, b3. So all of these are PicoLisp codes. And how about the miscellaneous? So it shows bench and Fibo. So there's the Fibo, which contains the Fibonacci function. So that's how you check each directory. You can also do some reading and outputting. So first, and also we can do this. Just now, so how about we enter? We can enter the miscellaneous folder. So then let me use the recall. So you see, so we are now in miscellaneous, and then let's try to print the, oh no, let's try to do some so here there's two files, so let's try to print what's inside fibo.l. So which would be in Fibo, then I'll try to use tab. So there you go, it autocomplete. So input Fibo, then we do a read. Then there you go, it shows the contents of the file fibo.l. So if you want to load that file so that we can use Fibo, we can do load Fibo.l. I think this is the right command. So there. Now Fibo, we can now use the Fibo function. So if we do some Fibonacci of like 4, 3, and Fibo of like 6. Oops. There, and it's working. So we have done directory, checking, then CD, then loading of file, reading the file, and then we can also write a file. So which is so how about we try to write the factorial, the function that we made earlier, factorial. So which is, let's try again. Let's try that again. Factorial of 4. So it's still here in the environment, but let's write this in the file so that when we reboot again, we have the factorial in the file. So let's just write it in this folder, the miscellaneous, by doing out function, which is out. Then let's just name that let's just name the file as factorial.l, and then we need to use pp to output the code so that you will see the usage of pp. Let's try that first. So pp and factorial. As you can see, it's just displaying the code. So we use pp to write in the file. So again, out file.l and pp fact. So now we have written our factorial function into a factorial file. So let's do a dir again. So there you can see factorial.l. So I think that's all that I can show for the file system. Let me check on my notes. It's so that's I think that's it. Out, I have already shown you out, and for the scan, there's this scan command which shows the file name with their database information. So I think that's all for the file system, and we'll proceed with yeah, I think that's all for now, and we'll proceed with showing you the device modules. But before I show you the device module, let me stop the REPL by invoking this command by. From there, if I input some keys, nothing happens. So how about let's confirm if that file was written. So let me restart the board, and now it's waiting for the enter key, so I press enter key. So as you can see, it's clearing the screen, waiting for 23 seconds for loading the file system and file editor. So let's wait for the prompt. So there, prompt is here, so it's ready. So let's do some dir. So yeah, there. But how about let's do dir on the miscellaneous folder. So there you go, factorial. So at the moment we cannot do factorial 3 because it's not loaded, so it's set undefined. So let's load factorial by doing load, and then miscellaneous folder and factorial L. So now it's loaded, then we can do that factorial 3 by, let me use the escape key. So there you go, it's working. So I think that's all for now. I will show you the device module that I mentioned that I plan to put or to use with PISCES. So let me stop PISCES first by the same command by autofocus by, and then let's shift this to the board. As you can see, the program counter is also stopping on some state. So if I press any key, nothing happens because it's already in stop mode. So here are the modules. First is this is the VGA and PS2 module. This module was intended for I think for Arduino board. So this one will be connected here. So it's connected here. Another module is this Wi-Fi module. It was also intended, I think, for the FPGA board. So which is connected here. Next module is this. It's an Ethernet module. Connect the LAN cable here. This was also intended for the FPGA board, so this will be connected here. Move it here. See board and the connections. And the last module is this touch LCD module. I think this was intended for Arduino board. So this will be connected here. So as you can see, there's some happening, but because the supply. But as of the moment, the driver is not yet, I mean the I/O ports are not yet implemented. This will be on the next release. So it's either the drivers for this module is in PicoLisp, plain PicoLisp code, or in the PicoLisp 64-bit assembly. Let me discuss with Alex how he planned for these modules. So let me remove this one. So I think that was all for now. So let me remove the modules first. I hope you enjoyed the demo, and so yeah, that was PISCES in action. So before I finally end this video, let me show you a cool feature that is still a work in progress. So let me remove PISCES from the host computer. So okay, as I have mentioned, the host computer can be any computer, any system that is capable of teletyping through the serial communication. So how about using your smartphone as the host system? And by doing that, first we need to supply using the power bank. On this demo I'm going to use the power bank. So let me connect connect the power bank port as the power source. So then as mentioned earlier, we need this jumper here to connect 5 volts out to 5 volts input. And then for the programming connection, because we're using a smartphone, so the communication will be through Bluetooth module. This is a Nordic PLE module that I get from one of my freelancing projects. It's very small, and the wires here are, I already arranged it so that it's easy to connect to PISCES. So violet or purple is for 3 volts input, and gray is the TX, white is RX, and black is ground. So yeah, this is 3 volts input because the module needs power. So that's the purpose for the 3 volts output of pin 1. So you can connect it. So here is the, so that's the Bluetooth module, and as you can see, there's no power yet because I didn't turn on the power bank. So let me prepare my phone. It's an Android phone because the app that we're going to use is an app made by Nordic for their demo for their UART application. So it's not designed to work as a terminal. So in this demo, you will expect some irregularities of the display. So okay, so here is the let me try to, so this is the app NRF and there. So let me turn on our banks. As you can see, the PC counter, the program counter is still waiting for the enter key from the user. So here, let's wait for the autofocus to it's the focus of the camera, it's a bit slow. Yeah. Okay. So I just paused the video so that it will not take long time to have a clear focus. So now press connect, and as you can see, it found the PLE module named PISCES. So if I There's this, so it's connected to PISCES. So now we need to send, as you can see, the program counter is not doing anything, so let me send an enter key, which is this, and then send. As you can see, there's PilMCU, then 15 megabyte heap. So then let's wait for the prompt. As you can see, there's the prompt. And then, because as I have mentioned, this is not yet a terminal app, so to send the characters to through this app, we need to send it letter by letter. So let's try the dir. So let me do oops no, let me change the input to, because this is set to Japanese, so let me change this to English format. So I have to pause it again because I need to set the keyboard to a non-Japanese keyboard. Let me do autofocus again. So okay, please excuse these pauses. So okay, we can try input dir and see if the, so here's the prompt. So let's send each letter by letter. D I R and enter key. So you can see it shows lib.l, lib folder, and miscellaneous folder, and the prompt. Then let's try again. Let's go to miscellaneous folder, which would be a bit longer command, but let's try that. Parentheses C D space, and then double quotation M I S C, close double quotation, close parentheses, and enter key. Then, as you can see, it shows that you can use your smartphone to connect with the PISCES board, so it's working similar as the microbit board. So let's just close this for now by typing by, or if you want to see some simple addition. We can also do that before we end this video. 9 plus, let's just say 6, close parenthesis, enter. As you can see, it shows 15. And we can also try that scan command or pwd. Check if so. We are now in miscellaneous. So we can try dir again. Maybe it will work. So yeah, it shows bench, factorial, and so. And then let's try last scan command. As you can see, these are the files shown, the output, but yeah, some missing text. This is what I mean for irregularities. So okay, let's, what else? Maybe we can load factorial and do the factorial. So load space and then factorial, the L, close double quotation and then close parenthesis and then enter. As you can see, it successfully loaded factorial, and we can do factorial space, then let's just say 5, then enter, then 150, 120. So I think that's all for now. And what else though? Let's properly close or shut down PilMCU by sending by. So Y E. Enter. So there you go. It's done. So disconnect, and yeah, that was the as you notice, the program counter is the same as the one we saw using the personal computer as the host computer. So yeah, that was all. So hope to see you again on the next presentation. Thank you. Thank you for reaching this far. I hope you enjoyed the demo video. As you have seen, there are still plenty of work to be done, and here is my to-do list. For PISCES to become a full-fledged embedded development system, the missing I/O ports need to be implemented. With this, the board can interact with other devices as well as the other existing systems. Examples are the modules that was shown earlier. Once the system is complete, optimization on both hardware and software will follow to boost performance. And once the system becomes robust and reliable, we can start developing the device drivers for the modules shown earlier using PicoLisp. This will be a great start learning PicoLisp as a low-level programming language. As of the moment, I can think two goals for this project. One is to get PISCES into the consumer market and become an alternative single-board computer like the Arduino, Raspberry Pi, and BeagleBoard. Another goal is it would be nice to have the PilMCU software ported into ASIC or fabricate into an actual silicon chip and become an alternative microcontroller like ARM, PIC, and AVR. So that's all for now, and I hope you enjoy the slides. My special thanks to Alexander Berger for his great idea and support. Because of him, this project came into reality. Also thanks to my wife and my family for all the encouragements. And finally, to all of you, thank you for watching. Have a great day and see you next time.